Okay, I'm going to do more C scripting, and today I want to build out an example for something a little simpler, which is just a way that I tend to use C scripting, the symbol set stuff in particular, uh, in projects where I'm actually building out uh, long term, like not just these examples where I'm sketching how to set up a symbol set, but when I start needing to use it more and more, I end up finding that I would prefer to copy the data out of the symbol sets and into my own uh, memory because uh, right now, whenever we reference a symbol set, I think I talked about this a little bit before. If I do something like sci address from ID, this is taking an ID to one of my blocks of data with the display name and the function or whatever, whatever it is I'm going to use here. What exactly we're doing? Save return. This isn't the best example, but because I don't remember the details of why we're grabbing this. Right. So here it's just reading what's the frame ID on this date. I see. Okay. So the point is that information is currently going through like this checked accessor that takes the ID, makes sure it's in the right range, and gets back the state. Now I could say do this unchecked, and then that boils it down to basically take the ID, do a -1 on it because it's a 1 based ID, and then access the thing. But you still have to kind of trust that accessing it through this macro is good. Like it is as good as it's going to get. If you really wanted to go further, you might want to remove that -1 and have these go, just into an array where the 0 slot is reserved and filled with null so that you can access it without doing that extra little arithmetic. But another thing that you might want to do is say, hey, I've got this ability to define a huge symbol set in the programming scheme, but when I build up one of my simulation systems or whatever I'm doing with my symbol sets, if you're thinking of it like a plug-in system for an editor, then this might make less sense. But if you're thinking of it like primitives for a programming system that is sort of not meta programming, but the C scripting thing, and you decide, okay, I can define 100 of these, but for any one of the specific runtime structures I'm going to build out of it, what I really want to do is sort of squeeze that down to 10 or 20 of them, or some interesting subset for whatever reason. And therefore, it might be nice to have a plan in place where I'm not just accessing the statically arranged data that makes the whole set that's available to the whole program, but to instead have most of my usage code go through an abstraction layer where it's accessing these from runtime memory, because then I can create squeezed down versions. If I don't do this step, there'll never be a chance. As long as I'm accessing this from the static memory of the whole program, there will never be such a thing as having fewer of them and accessing them right off that smaller array that I'm passing around. Now, there's two different ways you go about trying to solve that issue. The way I'm going about solving it is that I'm going to copy the memory somewhere else because that's very easy. But it's not necessarily the best way. The other way you could go about doing it is saying, well, the IDs are going to need to get translated. Let me write this down. Right? We have like these sci ID values, right? They're going to need to get translated into some kind of like local ID for the setup I'm talking about, and not every sci ID would, right? So you have these IDs, and what I'm basically saying is some subset of the IDs will get translated into local IDs, right? That's the pitch of sort of the relationship between the global static ones and then the ones that are going into a specific sort of submodel or something. And then the issue is you have like code blocks sitting around, right? So you have some symbol you've defined and it's got its name, and you write something like sci ID, do a thing and you say like thing A, right? Whatever. So you have a reference to a SciID, a symbol set ID through through this code block. And so this is encoded this way. And so then every API that these C scripts, if you will, are calling are basically going to have to do something like local ID equals translate, and then you have the local model and the SciID. You need some kind of constant translation from the statically stored IDs to the local models. And this isn't just a limitation with the language or anything. This is because the SciIDs are from the static, right? It's because it's like this is the pitch, is to the code has to be encoded with some statically referenceable thing, and so its ID is unique in the set of all statically referenceable things. If you're making subsets, then those IDs, right, they can't possibly, we're not going to go and rewrite it. I mean, I suppose that's the thing. You could run a compiler, right? If you wanted to, I guess you could take the local model and say, I want to recompile the code. It's just we don't have that much control over the C compiler. So you can't quite do that. But I guess that is worth thinking about as a possibility for like what you would really want potentially. But in lieu of that, you could at runtime translate the static IDs to local IDs. And so the fact that you might have to do that and that might suck as a thing to do whenever you access one of these might mean you don't want to do this thing where you copy the system down to shrink it down. But you would either way, if you were going to like one of the tricks that I tend to find myself wanting to use is that I can do stuff like let's put this somewhere else. You got some function somewhere and it's like I want to make a new array of foos where I get one foo back for each thing, right? And then I can go, well, whatever a foo is and the thing count, right? So the thing count can be calculated from the symbol set itself, right? So we have some symbol set, we get its count. And then this is saying, okay, well, I now want to assign, it's not a part of this what's statically known about the symbols, but for each symbol from this symbol set, I'm going to now assign a foo. So we're creating an array that it sort of extends what we know per thing, right? As long as we have this array, then in addition to everything else that you know that you can learn from a thing about itself, you can also learn what's the foo that's associated to you in this foo thing array, right? Because they're just these IDs. So what happens is this is useful up until a point, but when you start getting more and more like pushing it farther and farther, you might start doing things like, oh, it's not that it's just going to come from a thing, but there's going to be symbol count and thing count, and we're going to get a foo for each symbol and thing, and so now it's a symbol count and a thing count, right? And so because this starts to, like, as you have more and more, if you have 20 of these and 20 of these, well, now that's 400 slots, and it grows a little faster than just a linear, right? It's now like I don't know what you would call it besides it's the product of two different linearly scaling factors right now, and so each of these growing can sort of snowball over time a little bit more. So you might start thinking, well, this is where I do want to be able to shrink it, right? So the point of shrinking it down is not that we want the ID rewrite. This is not convenient, but the point is you might prefer to, because you start building these models where, well, we've saved like 1,000 things and 1,000 symbols, but we're trying to build one specific, piece out of that would only take 20 of each. And so the size of this sort of lookup matrix could be dramatically simplified if if you could make that mapping from the static IDs to a different ID system. And so, like I said, if you had control over the compiler, then presumably there's a way you could do this, where you could take a static reference to an ID and you could bake in and recompile your code for whatever subset of the IDs you actually wanted to index. But we're not pushing things that far. So instead, the trick becomes, well, these will no longer directly come from the counts. Instead, you'll make a struct that carries around, and this is what in my game engine I've been calling the rules. It just carries around all of the rules that were written on all the little pieces of the game, basically, right? Each C script is like something written on a rule book, or it's written on one of the pieces of the game that's like a card or a board or something, and it's got some text on it. And so each piece of text that you would put down to specify the rules of the game is actually code plugged into the rule system somewhere. And then what was just stuff you got statically becomes the variables of the rules type, right? And so this can go like foo symbol thing. And now, if you want, you can still get your rules from the C scripts directly. And then it looks like this. And at the end, you just go rules equals, and then you fill in all the rules, right? The rules thing count equals blah, the rules symbol count equals the other one. Right, thing count, symbol count, and foo symbol thing, right? So you can still just keep the whole thing, right, as one of your options, but then when you want to go build shrunk down permutations of your rule system, everything else references it through this runtime struct now, so that you have the code isn't going to be broken down later down the line, and it just goes through the rule system, right? That's the thinking of structuring this way. It really depends on how valuable it would be for any given symbol set system to imagine the shrinking, though. In the context where I'm working on it in my game engine, this feels likely to be useful, but I can totally see how in something more like a text editor, this would almost be irrelevant. You wouldn't want something like this, because you probably want an arbitrary amount of commands to just come in and out and be hooked into all sorts of contexts, and you don't want... There's no such thing as these minor scopes, I don't think. I mean, who knows? Maybe you want to make like sandboxing or something, and then as soon as you're talking about sandboxing one section of the plugin system from the larger context, then maybe all of a sudden you do want like a rules context type of thing. I don't really know, but it applies in some context, I guess, is the point, like, and not others. I definitely feel that this is only makes sense if the motivation of shrinking it down is somehow already clicks, right? Of shrinking down the symbol sets from the static set to something local. If that's intrinsically motivated somehow, then this is the way I go about doing that. And so the thing about this is that, so I've showed you a little bit of what this is like with this sketch. Let me go a little farther. So if I have some things, I have some symbols, the foos underneath are a little different because they are sort of like constructed. They're constructed out of something that's not arranged in memory the same way, whereas these are like direct copies, right, from the symbol set. So it helps to equip yourself with something like things equals, and then we could call this like arena push symbol set. And what you do is you give it an arena and you name a symbol set, and it does everything else. Right, so this one is different because you need some kind of like fill from, you know, the unnamed symbols. This is generally where that sort of thing might come from. So this would be like you have a bunch of, if we were to show, let me show over here what the corresponding symbols for all of these would look like. So we have a symbol. Let me just sketch out these different layers of this idea. So this is idea, localized, contexts with subsets of IDs, motivation, just accept it for now. Okay, that's better. Okay. And then no, it's just like you know, I don't know. What do I want to, you know, when you know. Okay, there you go. That's more like it. And this is the example of what you have to do to make the APIs work. And then there's the rules information that can be resized. And right, and this would also then have like dot things equals things and symbols equals symbols. Okay, so one way you could think about this is that it's like, actually, I give you the static ID. I'm not going to ID if we know that it's thing. So this isn't quite going to work as C code, but the idea is I think that the rules could carry all the information about how you translate the local context. I'm kind of designing this on the fly, I guess, in this video all of a sudden. But the main thing I wanted to make an example of was this, the arena push symbol set. And the reason that I think it's useful is because it helps you do this thing that I'm showing where you add an abstraction layer between the statically declared symbol sets and the APIs that access them through this rule struct so that you have the flexibility to, one, modify that, create modified versions of the rules that are smaller for whatever reason that you need that, and two, so that you can create these sort of extended processed things, these structures that get built up there. So maybe what I should do today to build out this example is just try to think of one thing that would necessitate two symbol types and a interaction between each one. Some type of interaction between those symbol types. What's something that's like that? I don't know if I can think of this off the top of my head, but I'm going to give it a shot. And while I sit here and ponder, if I feel like it's getting long and boring and slow, I will pause. But I'll try to keep my ideas out in the open so you can see how I might get there. So what's something with two symbols to interact? If one of them is a command, what's something, and we don't just want, because you could attach flags. Like I guess tags are a good example of this. Anytime you have something and then tags for that thing, then you have a Boolean interaction, right? Either for each pair, either this thing has this tag or not. It's a Boolean interaction. And other things like something richer, like that has a full, more complex interaction, might be a little harder for me to think of off the top of my head. Although I have some examples in my game engine. What are those like? Well, you know what could be fun? Okay, we could do a graph. Why don't we build just a general directed graph? I think that'll do it. It's not quite the same as this sketch where it's for each. It's not because you have vertices and you have edges. And then you might think, well, for each vertex and edge, I need a foo. What does that match? I don't know, right? I don't know what that matches in a graph. But what we can do is for each pair of vertices, pick an edge, right? Or we could make the edges. So this is interesting. Edges, you could either make them named symbols or not, right? They could just be information about the connection, the interactions between the vertices. Or they can be symbols, in which case what we're saying is for anywhere where there's an edge between two vertices in one of these graphs, it's not just an edge, it picks an edge symbol that represents some more information about that edge, right? Trying to think of if anything pops in my head. About how a static graph could be fun to program with, though. Static graphs are a little bit of a bummer in terms of like they feel a little bit. If it's really rich and fun to like, if it's a map for a game or something, then it's great. But more often than not, if you're dealing with something that processes graphs, you probably don't just want to process the graphs you can specify by hand. So it's more like you specify static graphs when they are like little kernels or maps or something that describes a little system in something bigger. They don't make very good statically specified graphs. Just aren't that compelling for graph algorithm stuff. Because once you want an algorithm, you probably want lots of runtime instances for it to work on over time, and those don't come from statically declared graphs. So what's an example? Use it. What's an example of using a graph? Or maybe it's not a graph. Maybe it's, or it is a graph, but it's like a bipartite graph. Each symbol is one of two sort of shades or colors of vertex, right? And the edges are strictly between the pairs of vertices that are differently shaded. And there's not an arrow, there's no directionality to the connections. So it would be literally this. What would be, yeah, this is literally a bipartite graph type setup. What would be the, hmm, um, hmm, 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 hmm. All right, let me pause for a bit and see if I come up with anything else. Okay, I've got something. I forgot about a good example that does this. So I'm gonna get started on writing it. What do I want to call this? I'll tell you a little bit about the example as I build it up. This is going to be the hooks.c and h example. Okay. Stack machine, your intro there, hooks. Don't know if we need any of this. Okay. So, the way this one will work is, first of all, we need the little base layer. And then we add in arena push symbol set takes an arena and a symbol set, and then it does a side type on S to get the type of the symbol set. Arena pushes onto the arena, and it pushes the size of that type. This could just be push array A, side type S for the S, side count S +1. +1 because I want it to give me a null, but I'm also I'm running out of, I can't do this all in one expression, I'm realizing. We'll just take, make this a little more big, okay. And then it's a memory copy from, to this spot from side, I think first gives me what I want, and side count S. I can also pull count out ahead of time. Just once, that way. But this all has to evaluate out to the correct. This doesn't return properly. Okay, so I give up on doing this as a macro. Instead, it's an arena push symbol set. Well, I'm confused. How did I do this before? To make this super easy. What's up? Let me go and look this up real quick. I have a solution. Okay, found it. Over here in the RPG simulators where I have it tucked away right now, so it's not even a part of my base layer yet, it's just in this other project. But the idea is that I can, this implements it, this and this implement it. So we're gonna just grab those real quick and rewrite them. And then I'll explain how they work. Why they're the right way to do it. But I'll also clean it up a little bit. So copy strided is a memory helper. Copy from C script raw. Copy from C script. There's the type. C script symbol set arena push symbol set arena push symbol set raw. So to specify your symbol set, you have to give the size, the beginning pointer, the stride, and the count all together. And then the macro just wraps doing all of that for you. And it types the return. Copy strided. This is more like a memory little thing, so that's fine. Arena push symbol set raw. Put all the symbol set stuff together on one line. How about that? Copy strided. Okay, so then I don't know. There's something a little not great about having a base layer for your examples. Like, you'd like for the examples to be sort of standalone, but then you end up duplicating a bunch of base layer stuff. So I can never quite decide how I want to structure a large like system of examples, but maybe in this case it kind of feels like you put them together because there's going to be a lot of stuff. Where it gets a little better if you integrate it with arenas a little more. It gets a little better if you have a scratch arena, etc., etc. So this is going to be the hooks stuff. So let me see over here. So hook is not it's not much, it's just a name basically. Okay, so there's your hook, and then you have to define one. I think probably you just do it like this. You just go like that, right? So now you can define your hooks. Maybe you're worried about the name hook being too easily colliding or confusing. So these are like hook points. You want to get a little more specific. These aren't the hooks, these are the hook points. And maybe that means a little more. A little more comfortable. Okay, so there's hook points, and then you also have callbacks, or what do we call these? Maybe these are like the instead of calling them the callbacks, they're more like the modifiers, hooks. I mean, in the RPG are the counters, which is part of what makes it very fun and interesting. But it's just a more generic approach. It's more like you have a process or something. Instead of calling it a process, though, we'll call it I don't know. We'll call it a process. I'm not sure what else to call it. It's gonna be like this. And is there anything else I want to say about process? Probably not. So we'll just leave it at that for now. Hook point becomes process. Hook point becomes process. Hook point becomes process. And hook becomes process. Now here, hook becomes hook point. Okay, good. So again, just storing its name. And then the third thing is going to be something I haven't looked at yet in any of these examples I've done in the video. So this is the process hook. It does not have a name. What it has is a generic raw address for a process and for a hook. And in addition to both of those, you've got some kind of hook function, right? And so then that looks like that. This is a process hook. And this is going to be different in a bunch of ways. So when we want to define a process, we don't give it a name. Instead, we name an existing process, we name an existing hook point. Oh, and that reminds me, this should say hook point. Define unnamed. So this is a process hook. It doesn't need to be named because we're never going to refer to this particular pairing. This is a pairing between a particular hook point and a particular ongoing process. And when I say process here, I'm not talking about like operating system processes. I mean like within your program something is going on. You have a text editor running and in the background it's also loading up symbols, or you've got a filter on that is searching for a particular keyword in all of your buffers or something, or you've got some kind of ongoing thing It's like a filter that you could just leave on and it does something for you. It changes how things work a little bit dynamically. Or it's like a ongoing task maybe that's going to complete eventually, but it's not done. It doesn't get done in a single frame, or that it repeats every once in a while or something, right? And it's not quite. This example is not specific. I'm just sketching out the hook part. All of those different examples are examples of things that if you're doing it would start to look like this, although they'd have more details and they'd be hooked into more, right? This is just the bones of the hook system idea. So the way you set this up then is you go, okay, I want to process ID equals sciraw RPG, or not RPG, we're just doing process, then do dot hook point ID equals sciraw hook point, right? And then, okay, how do we fill in a function? Well, we're going to go process hook __, and then I need a name that makes this function unique. Well, I'm okay with saying you only get one process hook per process hook point pair. And so that'll be the name of the function. Stick that here before the thing that makes the unnamed symbol that hooks these together. And I go, this is a void, and then so this has got to match this, right? This is the function we're filling in is this. Its type is return a void and take a context. So that's what this does. And then, you've seen this before if you've seen the other example, we've got the name of the function once declared here, and we can make it static if we like. And we've got it then hooked into the symbol here, and then this goes like that, right? So now when we define a process hook, we'll be able to actually put a function body on it. And then finally we need the sci_init. What I should really do is add this as a boilerplate to symbol set init or something like that, right? Like you should be able to come over here and go, okay, I'm including this, give me a copy paste boilerplate of the thing. But the thing is not that bad, so I keep doing it from memory. It's like that, and then for sci each process hook again, and then give me the links. For each one of these links, what I want you to do is fix the ID in process link process ID. Now you might be looking at this and wondering, hey, why do you not use the unchecked version here, right? You have unchecked, why don't you use that? Because you know you're doing it right. Well, the reason I do it is because I need to get a bunch of types to match correctly. And this automatically does the right thing when they don't match correctly, because this mentioning of the process here, right, the process symbol set has to match this one in order for this to work. And sometimes when you're copy pasting, you get mistakes, and so having it so that I'm copy pasting the unchecked one would mean more difficulty spotting those mistakes. But when you make a copy pasting error this way, what you get is just these all turn out 0 when they shouldn't be, and I find that less frustrating than you know, oh, something is crashing, get up the debugger, now I see where it crashed. It's a little bit unreliable for it to crash too. A lot of times it doesn't crash when you do it wrong. It just gives you like a garbage looking integer or something like that. I don't even know if it does crash, actually. That's why I'm taking that back. I'm like, wait, that's not even, it doesn't, I don't think it ever gave me the, you know, the crash here. Maybe if I was really smart, I wouldn't just check it and then put a 0 in. I'd assert in debug mode and then you'd see them, but then again, you have to pull up the debugger that way rather than being able to just press through when things sort of work, which is helpful a lot of the time. So I don't know. Anyway, just thinking through how I do this, but that's why I don't use an unchecked here, is the point. Now, what this has done is it's linked up the processes and the hook points. So for each process and each hook point, you get the opportunity to attach one function body. And so the idea then is that you would, in your usage of something like this, what you would be doing is you would say, okay, I've got a context. I have some number of these process things. So each process, you know, who knows how you get them. For now, I'll just say we're going to create some of them. And what I want you to be able to do then is go this. Okay. And so this is stuff that belongs in the base layer. I have I need to go get the stack machines. The rest of it's the base layer I didn't keep. And then here are the hooks. Well, I don't know, get some hook points like begin and hook points don't have any bodies. But then whatever the things are that when they exist, whether they are processes like I was suggesting in the examples I was coming up with, or, you know, they could be, like I said, counters in my RPG game, the counters on characters hook into the hook points to do stuff automatically, or, you know, effects that you've placed on the board of a game, or whatever it may be, you know, listeners, plugins. Maybe you have each plugin gets the opportunity, right? Each of these could be considered like a, instead of a process, like a plugin, and then the plugin gets one opportunity to say what it does on each hook, for instance. Or maybe these hook points work that way, but sometimes a plugin gets to say about more than one thing, and so that those look a little differently, or, you know, there's like more types of hook points, or they're typed. Maybe the hook points get typed, and then whenever you specify one of these, instead of just being like this, you get your params here, and then here you get the, you know, the psi type, or not the psi type, you'd get the something like your hook type paste HP, right? And you do the same thing we did with the frames in the stack machine before, right? You set the types up with a hook point, and that way each thing that registers to the hook point has the same parameters type, right? You could do stuff like this. So, you know, I'm explaining all that because I feel like this example is a little bit, is going to be a little vacuous by itself. There's going to be some, I don't have like a tic-tac-toe idea for how to make this relevant, except that I feel like it's sort of obvious when you're dealing with the plugin system stuff how hooks become relevant. Okay, so a process might be something like processes also wouldn't have anything directly on them like this. Process might be something like, oh man, I don't have any context for this to plug into yet, so it's a little, let's just say something like we're going to have a loop. And we're going to have something like run the hook for all processes side ID hook between frame and frame. So processes, like I was saying, maybe this is something like you've got an ongoing process that is searching for word across all your open buffers. Everywhere you look, it's got the ability to render stuff. So this would be like hook point render buffer, and then it would have process hook search word render buffer. Boom. What do you do when you want to render a buffer? And I go, well, I need to know that render, like the type. What's the type for the render buffer thing, right? So we're just talking about. So maybe I will build out an example of type hook, because I do think it makes it a lot more powerful. So we'll make that the parameters. And this one will get passed because it doesn't like that the parameter type pointer type got typed. It was supposed to be void, so the function types don't actually match like C wants, but we just say no. We took care of it with the cast. And then the issue becomes when we define a type. Right, we do something like that again. And so this would go, oh, and then these other ones are going to want no parameter. So we're going to want a type def version as well. And so the second one looks like this. The hook point itself may not actually need to know the size of its type, which is interesting. It might not need to know anything about the type, but as soon as we hook any of them, if they don't have it defined, it'll be an issue. Begin frame void, end frame void, which does kind of suggest that you don't need this though, right? Because each of these could just go line 1, define the hook, line 2, define the type, right? Like, that's cool. This is something I like to do when I'm building a symbol set. I haven't done this particular setup before, but just to play with how I make the macro declarations tidy and fun to work with. So point types at begin frame and end frame are voids, but the render buffer, hook point render buffer, is going to be a struct. It's going to be like, you know, here's your editor render context or whatever that you get, and here's your here's the buffer ID, and here's the you have like the view x and vy that is being used to render it, right? Just some stuff about how you're rendering a buffer. You pass it in here, and then you get some like pretend you get to call this will be like that. This will just do that, and go like pretend you get to do something like not RPG, add color word on the context from the params and whatever. Right? I'm not quite sure how to spell out an example for a host system without like a large plugin system around it and some motivation factor, right? It's kind of goofy, but like, you know, something like this. And then it would be something like I don't have any of the helpers set up for making this easy, like the types and stuff. So, you know, doing it like this would be something like that. And then these will just be like and you could imagine that you get the string from the process somehow. So how would that work? We can imagine that for a bit, make it more fun. But for now, let's say it's like imagine you get the match ranges from the params buffer. Then you color the ranges. Okay, so when I say imagine you get the string from the process somehow, you might think, well, what if, are we saying that there's only one ever copy of this? Well, if it's a plugin, sort of, but if it's like an ongoing thing, like search for a word, then not so much, right? So it depends on what exactly the layer of structure this is trying to model. But if what it models is, okay, for an ongoing process, we can do this, and then the processes are not like, isolated plugins, that kind of implies that you might be able to have other processes going on with other state, like a separate search word, for instance, right? But you might also say like, no, it's still just you get one or none. It doesn't make sense. That could also be a thing that's like this, right? It could be a part of the flags here that it's like process flag exclusive interactive or something, right? And so you can only have one of these exclusive interactive processes at a time, and if you start a new one, it kills the old one or something like that, right? But then the question is, what does it mean that this one has a string attached? And it kind of suggests that it's like this is a struct, and it has a string, and then this is like, okay, so the process wants to give me a string. Well, how does that work? Well, the process hook could do this twice. We could say, okay, we have a global context, and then we have two of these interacting things. We've got parameters from the hook, because the hook is like a function signature that we want to call, and so it's got parameters. But then the process has an ongoing state. And so given the current state of the process, we are prepared, then we will be prepared to handle the parameters for a specific hook, right? That's the kind of thinking we might be coming at here. And then this becomes process type PR, process, comma, right? So now we have access to not one, but two different sort of locally relevant variable slices that are typed by these static things here, right? Process ID. So then this becomes like the hook one, where right, so now we have a process type that we have to define with our process, and so this process is defined by a struct, and that should now be able to access this process and this params at the same time. buffer render context does not do that. That doesn't. Okay, so no. That's what we're saying. Yeah, no. I don't really do it that way. I feel like it's a bad idea. So the thought I was pursuing there is that like sometimes it feels like you'd like to be able to make the C script speak to a specific context designed for the APIs that it's allowed to access. And it always feels like it's going to be so clever. But the truth is the combinations of APIs are so often so overlapping, and the work of setting up these micro contexts so weighs down everything else that I just don't like it. Maybe if C scripting got good enough to the point that I could sit and like sketch out an API so that I have like a matrix of API points interacting with hook points or something like that as symbols, then I could figure it out. Like then it would be manageable. But as it is, I don't know how I would do a good job with something like that. It still seems like just too much. So I'm backing off of that idea. But I still want to figure out how I can set this up. So I already have a struct called process though. So this is like this. I haven't even gotten to the rules part yet. I'm totally bogged down in the hooks because the example I came up with was hook. It's fine. It's fine. I'll just back off a little bit here. So this could work. I'm not going to pursue it. Let's back off a little bit here. The process type is going to go away. It's a cool idea. It's probably what I would want in a system like this. But you know, I don't have a real context to test any of this against yet, so it's a little bit of a leap. So this can just simplify back down to this. This will just be this. This will be straight const C scripting. Imagine you get the string from the process. I can also provide that as help, so you don't have to figure out how to spell the hook point types yourself. Okay, and so then I say give me the type. Since I know I'm calling the render buffer hook, I'm going to get the type of the parameter block for that. And I'm going to say params.bufferid equals view buffer equals buffer ID. So these will take nulls because they just don't have parameters. And now let's go implement these context functions real quick. So this is like if static void context new process ID static void context hook call processes hook ID branch. Right. Now, obviously, stuff I've left out is like a process probably wants the ability to say in one of its hooks, hey, I'm done. You know, if it's like search word is a thing, it probably wants abilities to hook into, like, again, hooks don't make sense when you don't have a big universe of functioning input processing and displaying of some kind of information to hook into. So I'm just making up kind of a skeleton, and it's a lot of the real work would go into adding in that stuff of like, what does it mean if a process wants to close itself? Is that a thing? How often is that allowed? Do all the things I want to use as processes really make sense that way, or is it kind of like only one of them that I'm more interested in and the other ones won't work that way? That stuff is tough. I'm not saying it's not, but having the ability to sort out hook points and symbols or processes, whatever you need, this way, it means that at least the figuring out like, oh man, I have to change the enum somewhere and then I have to go and find the switches. It's like this sorts that part out. You can now organize things in very natural ways when you're setting them up, and you can even like declare things in different order. So like you could imagine this is a part of some sort of like a file somewhere that gets the main thing up and running, but it's actually not until later on that you start allowing these process things to hook the rendering of buffers. And so this shows up sort of later and is organized a little differently with the other processes that hook it or something like that, right? This fact that you could then, this also means that like if somebody starts building a extension to your system and you're allowing them not only to make processes but new hook points, that then they can build up, say, I in my case, for instance, I have this built on top of the stack machine stuff. So different states can then say, okay, I'm calling this and this hook in this particular frame, right? This frame has two different states that are each going to call a hook, for instance. And that way, when I go to add a new kind of frame with some new states, I can add the hooks that they are going to introduce as well. And they define when those hooks get called. But then the process equivalent in my system, which is the counter, that hooks into the hook points, those can be defined and can ignore that those hooks exist. They can work whether or not those hook points are actually, again, the idea of being able to shrink it down to a subset. If the hook point doesn't need to be known because it's a part of a piece of the system that's not in use in a current instance, then all of those hook points are totally irrelevant. There's not like some central control over what the hook points are. And that's a little unique. I think that makes it a little different. There's still like here, it's the main is the central point. So like all of this is centrally controlled hooks still. But you can see now that the pieces are in place, hopefully, for a plugin system that has these hooks, or a hook system, I should say, where defining new hooks and calling them is perfectly available to every level, including the plugins that are already implementing hooks for previous levels in the sort of chain, right? It becomes flexible enough to do that sort of stuff. Not that you want tons and tons of abstract hook points all over the place, but it's a useful structure, and it's a good example of an actual bipartite relationship, right? We have hook points, we have the things that plug into the hook points, and then we have the thing you do at that hook point for that pluggable piece, right? That is, each one of these functions is therefore an interaction between a hook point and a process, essentially. Okay, so what's left to do is just to fill in these little functions here. And then this will be the context functions. Right, so we just save the new process ID, because that's all this supports in this little example. And then here you go, okay, loop over all of the processes. Get the process ID, and then this is where we want to be able to talk about the rules, right? So this is where we go rules, hook, func, from, process, hook. And this would be like going context, rules, process ID, hook ID. What comes back is the hook function. And so if that is not 0, then we call it with the parameters and the context, right? So that's the idea. We want to get a function from the rules. Now, where are the rules? We are now arriving at the original point of this example. Hook point count, process count. One thing you might do is say, if we're going to have multiple processes, then each process might have its own state someday. Then really, these are more like process types, right? It's like different types of processes that can be going on, and so maybe I try that as the name, because it is a little uncomfy to use the name process bear like that. I think I replied with some operating system header sooner or later. Right, process type. ID, process type ID, process type ID, process type. Okay, that's probably most of it. And then the rest of this still has to get written. So, oops, not like that. Hook points. Process type, process types. Then hook functions function from process hook. And for these, I've gotten into the habit of using a little notation to keep track of how these things are sort of indexes into these things, right? So these are the ones that have names that can be statically referenced, and they have counts that are relevant. This comes from the process hooks that we specify up here that do not have names, and it organizes them in a specific way. It says, I want to be able to first look up by process type, or I want to basically take the indexes of the process type and the indexes of the hook ID, or the IDs of each of these, and smush them together into a single index and look up a function from that, right? So that's what it says it wants to do. And then what we need is, for one thing, rules from symbol sets. This will take an arena and it'll create a copy of all the rules that you can get from the symbol sets themselves. And then we also want one that's like, get me that hook function lookup. So I go to my rules and I get my function, hook function. Let me just call that the function. Shorten it a little bit. It's got the word hook in it anyways, where it actually counts from process hook. And so that takes in the rules, takes in the process type ID and the hook point ID. Which I guess is what these should actually be doing too. Yeah, that'll be good. Okay. So implement these. But do something like this. Arena push symbol set, arena hook point. Process types. Alright, so now we get counts, we get the pointers. The one thing I have to do, so this is copy the named symbol sets. And then we have
process the unnamed symbol sets into some kind of data structure that preserves the information that they were trying to attach and equip or add into the definitions that were not part of the named symbol sets. And so what I do here is go hook func process hook equals push an array onto this arena of hook func pointers using the hook point count and the process type count. So a couple comments. The reason I'm doing +1s here is because this is set up to save a null, so like it creates an array. Remember, these IDs for the symbol sets are 1 based. So what it does is it creates an array that has 1 extra slot at the beginning that is cleared to 0, and then copies the symbol sets into the rest of the chunk that it allocates. So what I get back is an array where I can literally put in the ID of a symbol, and out pops the copy of that symbol's data, right? And this macro, thankfully, like type checks this, so that would help me identify the mistake there that I just fixed. I caught it myself, but sometimes having the macro do this type check wrapping is nice. And then let's see, process the name symbol sets, push array, arena func hook point count, process type count. So there's all of our function matrix, but we need to fill it in. So the way we fill it in is we do a loop over the process hook links. Now, we have all done this before already. Here, we were doing it during scinit. This is the time set aside at the beginning of main to fix up the IDs. This will happen after scinit. Right, this is going to be something like let's give it 10 megabytes for this program. So copies the rules. This wants to keep a view on those rules that it's playing by. So then here I'll just do it unchecked. Func process hook becomes, okay, so process type first. That means that's the higher order one in my mind. Process type ID times rules hook point count plus hook point ID. Right? That should do it. That gives me the right expression, at least, to get to my function. I'll just shorten these lines down a little bit. They're not doing quite so much. And then what happens here, we have the IDs, they are properly processed, so func process hook gets the process link process type ID times the hook point count plus the link hook point ID, right? So again, same basic formula for the index, except the process type ID and the hook point ID are now coming from the link that's initializing it rather than from a parameter from the runtime that's querying it. And the count is not coming from the rules, but is a part of this like local setup scope where we're creating the rules still. So, you know, it's all a little different this time, but the formula is the same. Process ID times the hook count plus the hook point ID. You get the index, and now we're not reading it, we are writing it, and the link has the thing we want to write. The link is the series of assignments into this matrix, basically, right? For each link, we do an assignment in the matrix. It has the coordinates, it has the thing we want to assign, and then whenever we want to read it, we read it out, and if there was a link, you know, if the unnamed symbol exists for that pair, then when we put that in at runtime, we should be able to just find it and run it, right? That's the idea. That's the idea. Something is off with my scrolling on this setup. I've been feeling it today. Like, look at this. It's like I'm just scrolling a scroll wheel, and then it does this like chop, 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 chop. Something's off. I don't know if that's 4Coder or my mouse wheel or a bad, or like my config, my desktop config, but or a bad combination of the two. I'm not sure. Okay, let's get compile. What is it called? Build with playing sh. We've got stack machine as a mode. Let's try hook as a mode. Okay. So build this. Did that really just work? Did you just build? And then project. Can you run hook? Is that fair? I don't have any scanfs this time. Example one is hook. Load project. Oh, I'm in the wrong folder for one thing. Let's just drop that, restart. Okay, so you're saying no, you don't see hook. Build with Clang. Oh, I still have to change this manually because that sucks. Okay. Examples, hook, hooks. Okay, build with Clang. Replace hook with hooks. Okay, so that builds. Hook not found. Right. What about hooks? Run hooks. Run hook. Run. Wait. Hook. Run hooks. Load project. Build. So we're going to add that to the little mini base this time. I don't know. Maybe I don't collapse it. I don't know. Never know. Define min a. A is less than b. Then a, otherwise b. What do you mean? These hooks. Oh, you don't even know about the hooks. Process type now. Okay. We need to do a double pointer for this one because it's an array of pointers. Right, and so that's just presumably going to print like, what is that, 200 iterations, 100 iterations, render. Buffer. Oh yeah, 2 views. Okay. I mean that roughly seems like the demo. We've got the rules thing. I just don't have a lot more to add to make it more rich, unfortunately. Hooks are a little less just immediately powerful until they're hooking into something more interesting. And yeah, that's the way I do it though. So that the 2 things I guess I ended up showing off here are the arena trick, which is just, to have a helper that's like pass in an arena and a symbol set, and out you get the copy. And then also this idea of setting up, well, I guess it's 3 things, right? And then this idea of setting up a separation layer with rules using that. So that's all one thing to me. So that's 1. And then 2 is the hook pattern, right? Setting up hook points, things that plug into those hooks, and then the pluggability part. The plug itself, the hook functions come from these interactions between the 2.